we actually calculated a little bit about like this the unit size, especially for the studios, and then we also somehow get rid of those skylights, especially for these smallest units. So for this change, that would meet the 500 square feet limit, the lowest limit that we have to pass through. And then, so for the skylight issue that is kind of disappeared in studio units, and then we replace it with having kind of like a vertical skylight that there is a like the space below would be used by like the studio units, but there is like a glass upstairs, so there would be like a glass roof that covers the units, and then that would be it. And I think there is another section that might show. Yeah, it's actually something like this. So, but the only disadvantage of this design change is that this skylight won't be able like to pass through all 3 stories. So this would be only be like connected from like the first floor to the second floor, which is here, which can see through like from the ground to the communal common area, large area. But it doesn't connect upstairs, so you can see it hits the floor of unit 10 and 11. So, but for this case, then these 2 studio units can also meet the 500 square feet limit. As you can see, like the partition is kind of like, it's not really symmetrical, and yeah, we just adjusted like the width between these 2 units to fit all the figures. And then at the top from here, you can see the skylights is right above it. So I guess that would be like the compromise that we try to get, while the other units, like this one keeps here. So you can see this skylight on the left is still like containing like a void kind of a condition that passing through all the way from the ground to upstairs. Yes, from the section you can see here. So this would be like the skylight on the left side. And this area would be open because there is nothing upstairs. There's no units here. But for this one would be just connecting 2 stories. And then this kind of like more individual skylight would be shared by these 2 studio units. And then more from that is actually like the largest change from here is to enlarge like the grid scale. And other than that, we try to manage like the utility core, as last time the design partner mentioned about. And I think I can show you from another file which try to indicate hold on a second. Try to indicate the waterproofing areas. Yes. So from here, I'm trying to demarcate in, let's see how many colors. Yeah, 2 colors. Like the yellow color would be the areas that is somehow exposed to the outside world, while it is kind of enclosed by the walls and stuff. So you may need to put like specific kind of additional kind of waterproof layers, while these orange areas are like the waterproofing layers that only applies to indoor areas. So for this one would be like where the utility core goes, while this one is the manager office, and this one would be like the laundry, because like laundry involves a lot of water work, so it should cover the entire room. And then similar utility core configuration repeats here, which the unit approximately has a dimension like 13 times 13 feet, but I can give you a more definite dimension about it, and if you look through the plans, and you can also see I tried to subdivide all the walls into different segments, which I'm trying to do this arrangement by like there would be a range of a width of 12 feet panels to 13 feet 6 inches panels. Yeah, so for this I'm trying to rearrange and trying to get an idea of like how many variations of panels that we are going to get here. And then for the podium, which in previous times, the engineering team was kind of concerned about like the waterproofing, and then I think we should stick with all the floor areas that is outdoor, no matter it's covered up above or not, would fall into like the yellow kind of classification. So so this would be like the area for you guys to have a more clear understanding and to do the calculation in terms of the area. And while the utility core also gets involved in terms of these standardized dimensions. And then there is a few things that I've kind of added is since the change of this grid dimensions result a little bit of residual spaces, for example, this area. So I think this area would be useful to do as a pipe duct or an
falling wall.
Yeah. Just let the routings to go around the floors and spaces, and these would be the access panels for people to maintain, and then they just open up the panels and do their stuff. So it would be easily accessible. And it's also kind of close to the open area, so the impact for the maintenance should be able to minimize. And then and then this area would be the skylight, as I mentioned, for the lower floors for the studio units. And then upstairs would be in similar cases, while these areas would be covered by solar panels, kind of like a balcony upstairs, but we still kind of allow to do the waterproofing stuff all across the inaccessible roof and then the flat roof. And then so these so this one is actually kind of like a kitchen area, so you can only see kitchen sinks and stove, but we just still try to treat it as size more or less similar to a utility core. So so these also repeats from the first floor configuration. The only difference for the studio units all across the floors would be the partition walls in between. The one on the first floor is kind of in the middle, but this one is kind of shifted. And then all the way up would be solar panels and then skylight. And then and I also have a waterproofing kind of demarcation section. As you can see, the color also reflects what I've just mentioned here. For example, if there's areas that involves toilets and the utility cores, and then that would be in orange, while the other, like the flat roofs above the living units, would be in yellow, and then all these also for the same case. And for this one is actually like covered kind of open space, which is like the area that's here. So that would also fall into like the waterproofing area that is related to the outdoor kind of treatment. And this one, yeah, would be similar. Yeah, it's kind of, yeah, I think you can understand it. And so in terms of like the structural kind of concerns that the engineering teams mentioned about like some of the floors, like the squares are not perfectly aligned. So for here we try to overlay like different floors, and then we added several columns. And then for these, you can see it's kind of like rectangular shapes, and it varies in sizes. So we put it in these kind of like configurations, which is determined by like where is the junction or like the interface of each of the panels. So like, let's say for this condition, so for the floor underneath, that would be like 6 times 6 inches kind of like column, while the other side also shares one. So like to combine, there would be like a rectangle of like 2 squares, and then these would be like results of the the panel arrangement or subdivision above. So what comes a little bit awkward is here, which you can see like that there's a mixture of like more or less a structural column versus a more typical drywall installation. But I guess is still fine here, because it can also like determine like the division of the rooms inside, as well as like, since the thickness is has a difference of 2 inches, so I don't think it's a huge issue in terms of like affecting the interior layout. And yeah, so for here, like the podium, which covers about here, and then there would be like columns, and then and for the car park, there's, so last time we mentioned a little bit about like the podium, like some part of the podium would be constructed in like a steel superstructure. So in here you can see like there are like two rows of square rectangular like columns. So these areas would be like related to the residential units or panels above, while these areas here would be the steel columns, or like the columns that are related to the steel superstructure above to support the podium, that we can, for this case, then we can somehow isolate the structural systems between the two, and then to avoid like a more complicated interface between the steel systems and then the wooden panel or floor slab structure. So for here, the spacing is still kind of falls in an acceptable range. So you can see like the division does not really affect the layout or the placement of car park areas, and we can still meet total number of 12. So that still meets the requirement here. And then I think for now, the only more details we have to develop is like really have to generate like a list of panels that we are going to use throughout the entire building structure, and as well as like giving out like the basic dimensions of like the windows and openings. But I think we for this case we already kind of have a predetermined dimensions, which I think you can like for engineering teams, you can make references from the other drawings, like these sections, like the windows, and then there should be like the smaller ones here. And then I think for like the giving you like have a very kind of simple kind of like a starting point is like the window that faces like a skylight would be like more or less like a full height kind of window, but like the only variable would be like the width of the window. So you can see like the bottom of the window touches like the ground, and then for these would be like the buffer space to leave for the structural elements that may happen above it if it's necessary, in order not to hit any kind of beams or whatever. And then for other more typical windows that spreads around like the perimeter of the units, like here, and here, like the vertical clearance would more or less be the same as this one, and this would like the only variable is also would be the width, and like all the vertical dimension is kind of fixed, so it only changes in terms of like it may spread longer or spread shorter. And yeah, so that's more or less the update that we have here. And yeah, so in terms of material, and I think we have started like to sort a little list of materials that we think it may be useful like to place indoor and outdoor, in order to have like a more concise estimation in terms of like the cost calculation, as well as like the environmental impacts, which there should be like EPD fact sheet for each of the material that we're going to choose. So I'm not sure if Ellen has posted any materials to you guys yet, but yeah, we are starting to work on that. Yeah. So is there any questions specifically for engineering teams? And
I have a quick question, Hayden. So
yes.
Looking at your section, I'm just wondering the width of the thickness of the floor that you have.
So
like,
for here, presume all the floors are 6 inches thick, but I'm not sure if that's like the norm.
no, it has to be at least 12 inches.
Okay, 1 foot.
And
Okay.
that is just the size of the floor joists, and you have to add in like the panel, like the floor panel. It's typically 3/4 thick, 3/4 inch thick, and your flooring, and then your chipboard at the bottom, like all of those kind of things that we need to like. That's gonna add to the thickness of the floor.
Okay, so let me quickly look through the my sections. Hold on a second. Okay, like as I mentioned, like there is a buffer zone from this line to here, right?
Right.
Yes. So this like the distance would be 1 feet and 4 inches. So for this for for your case, then thickening the floor slabs into 1 feet should be able to adapt all scenarios in all.
For the inner floors, yes, but for the podium, I think 4 inches should be enough. Like 4
Sorry?
to 6 inches, because I think it's possibly going to be a composite steel deck. So typically it's like 4 inches to 6 inches, like.
Okay, so like let's say the steel part would be 4 inches, but like the main structure would be like 1 feet thickness, right?
Yeah, minimum.
Okay, then yeah, then of course we can change like to 1 inch, 1 feet thickness, but for this case we still have 4 inches buffer to the full height windows that we're planning to put in. But of course, if it requires more thickness for like the floor slabs, of course we are able like to do the changes. Yeah, basically there is not much that really hits the ceiling.
Yeah, as long as it doesn't hit the window.
Yeah, but of course we can change that if that's necessary.
Right.
Yeah.
Yeah, if I can add on to that, I think I was talking to Sterling earlier about like these podium deck systems. Maybe I can give like a short presentation on that, because it's one of the things we talked about with Todd. And I don't know if we don't have to do it, but it seems to be a pretty common solution for these kind of deck systems. Just share this.
Okay.
So the PDF for this is on the Miro too, on the right hand side. But essentially, these systems are like these series of these kind of plastic pedestals, and they're kind of height adjustable. So the idea is that you can
Gavin.
put. Yep.
Sorry, real quick. I can't see your shared screen. Hayden, if you wouldn't mind unsharing your screen for just a sec.
Thanks.
Sorry.
Sweet, thank you.
Cool. Everyone see this? Yeah, so it's essentially a series of these kind of plastic pedestals. And the idea is that they're height adjustable, so they can go from basically like I think it's like 2 or 3 inches to maybe or even less, all the way up to like pretty tall, in order of 1 to 2 feet.
I think
higher.
I think this one, like this system works because it's pretty common like to use for the outdoor kind of surface kind of treatment. And it also like allows like the water like to seep through the surface and go downstairs to do their drainage. But like I think like the footing system is totally fine, but like the only decision that we really have to choose is like what really puts on top of those footings.
Yeah, there's essentially kind of 2 general strategies. One is like tiles, where you just have tiles and they only span between these, or you kind of have systems where you put joists on top and then you can use like larger sections of boards. So probably just come down to whichever one's cost effective. Like the tiles have a lot of, I guess, flexibility in material types, which is kind of nice. So you can kind of do different zones with different types of tiles. But yeah, overall the system is pretty simple. You can see it kind of being installed there. You basically don't have to do anything special to the upper roof. You kind of build it just as a normal roof, waterproofing and everything, and you just put these on top. And here you can kind of see what one of the drawings would look like. And there's like 2 different tiles coming together. So there's another drawing down here. And there's other types. You can use like trays of rocks and sanitars and things like that. So here's what a drawing might look like. So here, these are like kind of central drains. And then you can see that the different heights are kind of arrayed along the different sections of the roof, and the water's still going through the drains. I think the thing that if we were going to use one of these systems, we just need to figure out what our draining strategy is going to be.
Yeah, but I think like the drainage point would be the best to stick with closer to the perimeter of like those wall panels, and for that we don't need to put like a lengthy kind of drainage pipes, and then But I don't know if that may affect like the performance of the walls, because like the drainage point is too close to that. Or
Todd seemed to think it was okay during the meeting, basically that either most people would choose to drain to the outside and use gutters, or drain to kind of interior kind of walls, and then like interior plumbing walls, and then it could just go straight down the plumbing wall, either to another drain in the basement or to like some sort of storage.
I think like one strategies that we can take is like, because from the latest layout I just showed you before, like there are like a number of like columns that are like standalone. So like the pipes maybe can attach one of those, then we don't need to like build strange pipes that are coming out of a wall from middle of nowhere, and then yeah, just somehow to conceal like the water pipe work.
Yeah, I mean that would be great if we could just would they be external to the columns? They would just be alongside the column, and we would punch a hole in the deck for both the drain and the column to go through, or the drain to go through is alongside the column.
I think what I mean is like the vertical part of the pipe that going up, like going down to the ground, maybe like would be the best to attach one of those vertical columns, in order like to hide awkward moment when there is like a very wide range of flat wall panels, but at the middle there would be like a very strange and ugly kind of pipes that just spreads out, like cuts through the beautiful flat wall. Yeah. But I guess the engineering team like can have a look like which part would be the best to insert the drainage points, because like as you can see, like the how to say, the shape of the podium is kind of irregular, so I guess you may have to like to subdivide into 2 or 3 regions to to set up their localized drainage areas. And then
one other question I had, which is going back to what we were talking with Kaiji about earlier, was like the thickness of the floor slab. So like in this scenario, I have the floor slab as one thing, and then since we have a mix of like modules and panels, the modules themselves have their own floor section, and then the module, that's one kind of unit that's made together, whereas the panels don't. So there would need to be either the module itself would need to be like set down somehow.
Yeah, I think that would be the case. Like whenever the module sits, there would be no floor slabs that that kind of lifts it up. Yeah.
Okay, so then in that case, we almost definitely would need to support like places like the edges of this, because the module itself is being the structure.
Yeah.
That's just one thing to be aware of. And then I guess in that case, we still would want to raise the floor a bit so that it would be flush with whatever kind of decking system we'd be using outside that takes up a bit of space. But I guess it doesn't have to be much, right? But the deck of the floor inside the module area would be built up of whatever assembly we chose, like subfloor and some sort of finish.
Or let's say for the worst scenario, maybe like, because for this condition, I was imagining like all of the all the modules should like share the same height of like the 10 inches kind of thing. So I did not really leave like the additional ceiling plus flooring kind of thickness when it's like stacked together. So I'm not sure, let's say, because for the current layout, maybe I share my screen again. Okay. I think the condition may happen in here. For example, this area, because if you look back down, it should be somewhere here, which there is no like utility core that sits perfectly underneath. So what I was thinking is maybe we could add some of the like columns like these ones in order to support, or yeah, but I'm not really sure if because once if we really raise all the floors, like let's say for a foot, I think I'm not sure, but just one thought, like there is no specific height limit for this project, right? It only have to fulfill like the building code and stuff, right?
Yeah, just the code limit.
Okay.
I don't know.
Then the only, let's say if we really had to raise up the entire floor by, let's say, an inch to fit the additional ceiling thickness for the modules, I think the only change that we have to be done is to add steps for the staircases. But I think that may not affect a lot in terms of the layout, because there is still areas for us to buffer. Like, yeah, there are still spaces for us to put more steps, as we have to lengthen the staircase, since the vertical separation is kind of widened. Yeah, but I think at least from my perspective, like I think maybe engineering teams can have a look if like the support is really necessary, like to, or maybe engineering team can point out where should be the I think I mistakenly, okay, yeah, or maybe engineering teams can have a look if, let's say for this scenario, like any additional columns have to be put in order to cover these spaces underneath, as to support the utility cores. And yeah, but for the current layout, I think we should have we're aware of that, like trying our best, like to stack up all the utility cores. But for example, here it goes all the way down here, and yeah, just yeah, maybe engineering team can check it out. But of course, if it's really the case, have to raise up the entire floor, I think we still have the ability to adapt the changes. Yeah.
Okay. Yeah. So I mean, I think we should probably try to avoid it, just because it's, you know, duplicated material and stuff. So in setting in and then using the column supports makes sense. One last thing we talked about with Todd was plumbing cores. So he kind of advocated using these plumbing walls, which generally run totally kind of vertical through the building, and then all the plumbing and other utilities kind of connect up to these and then are able to run vertically. And the same goes for like the ventilation, they run vertically up them. Mm-hmm. So generally that's an 18-inch to 2-foot area that's kind of hidden. And in this sense, it might make sense to do it, you know, behind so plumbing areas, or in inaccessible plumbing areas, like.
Yeah, so for the utility core that we have drawn, there's actually a really thin space that accommodates the utility wall that both Todd and the design partner was mentioning.
Do those
but
run vertically all the way through the building? Just
it's
per
not
unit?
entirely run through all the building, but I pre-assume all the utility core should have such setup with these. But even without like the vertical connection, but I guess from here, like from this section, you can see
those lavatories would form a
yeah.
yeah.
At least for this cut, it perfectly runs vertically. And even not, for this case, there's still like a pipe duct area, a very thin one that allows something to go down through here and then, and get things out.
Okay, great. Yeah, that's just something for the engineering teams to be aware of going forward, is that that's how the utilities are running, is through those.
Yes. And some kind of like a side notes, like since for these, some of the locations have like these kind of like really weird thin gaps. But I did not like widen, like extend the washroom all the way to touch the end, is because this area is kind of like a fixed dimension, which is like a part of the utility core, while like extending it would like explode the entire block, like the module, so it doesn't work. But at the same time, if I decided to shorten, like to move this wall to here, one part, it also like affects like the wall portion of the module, and the other part is that the shortening of this portion, it also affects the width of the panels that I was mentioning, that we are trying to standardize and lower the variations. So I'm not sure if, if this part can also be like a part of the drainage or pumping kind of area.
Well, it would be a plumbing wall for the shower, right? Like,
yeah, that could be, but for these two scenarios, maybe that would be like an additional part of the pumping areas, because not all units have the same kind of conditions. Yeah, or maybe I can show, like for this one, it has an even wider gaps. So for this case, I just set like a very small panels for maybe wide enough for people like to sneak in and do the checks, as well as connecting with the pipe ducts here. And let me see if there is any more upstairs. Yeah, I think like the strange gap that happens is only exists on the second floor. Yeah, which is here. This is not the strange one because I intentionally put this in here for the kitchen. And I'm not sure if like the storage space should also like contain with like this specific kind of like orange type of waterproofing, because I'm not sure if there's like a water related pumping drainage stuff going on here. So yeah, so
the HVAC, I don't know. Yeah. What are the engineers thinking for that space?
Yeah, so maybe engineering team can also have a look if like water connection is necessary to go through this space, and then, but that's not a major kind of changes for us. Just add more. The only change would be like adding more coverage for waterproofing materials. That's it.
Yeah, if I could chime in real quick. So I've actually been looking through, so this, I had mentioned last week, there was this ASHRAE Zero Energy Guide to, it's actually the document is for small to medium office buildings, but like multiple dwelling units kind of applies to some of the same criteria. And I was thinking about like different sources for hot water, and one of the things that they actually encourage is using ground source heat pumps, which is just like either using the whole idea is that like 6 inches under the ground or something below like I guess grade, you have like a constant temperature of around 50 or 55 degrees, which you can either use as a hot or a cold source and like a heat exchange. If we were to use that as like the hot water source, we could potentially use that storage unit as like the main distribution center for that, like for I guess the water system itself.
Okay.
I don't know. The thing is, when we're thinking about like hot water moving to all of these units, we have to consider that there's going to be some sort of central unit, and then there's going to have to be a way to I guess
Distribute.
move to each of some of these plumbing walls.
Mhm.
So I don't know the specifics of how that would work for getting to different parts of the site. But I'm actually looking at it right now, and by like hopefully by the next our next sub teams meeting, we can kind of coordinate and get back to you on what we think. Oh yeah, Adriana just said that we can talk about it this week, so we'll definitely get some more details narrowed down for by next week.
Sure. And I think, yeah, that makes sense. So for that one, does it mean it would be something like a boiler room, but it's more an advanced kind of like boiler room that do the water heating stuff, right?
Right. So what a ground source heat pump would do is eliminate the need for a boiler. And like it saves a lot of space.
Sure.
So like we like that size for like a storage unit could definitely I guess accompany that the sizing requirements for this
Yeah,
area.
sure. Just yeah, this one is more is super flexible because we don't know like how much storage we actually need and like how much laundry we actually need. So yeah, just
Right.
propose us like a size for that, and then we make adjustment. So
Totally.
because yeah, this is like super flexible, this area. We can leave
Okay.
it all to you.
Awesome.
And-
Yeah, sounds good.
Hey,
but
Gavin.
there is a like a very rough idea, like it's just randomly pops up in my mind. Like I think like the major routing going upstairs can go through from this pipe wall, like the very thin area here. I don't know if that's enough, but anyways. And then going up to the second floor, and then the pipes can go all the way through the ceiling of this area, and then just to branch out to different areas here, going here, and then some of them may go back down if that's necessary, and then to connect with the, yeah, just some kind of rough ideas. But yeah, you guys can do your own studies because yeah. Okay. So any more thoughts?
Yeah.
Yeah, go on.
Real quick, Gavin, when we met with Todd Lynch, didn't he mention something about like the bathrooms needing like a certain radius for like you should be able to move like a certain amount of feet? So
Yeah,
the doors.
he did also mention ADA requirements for accessibility. Oh, and I did forget about this, but we talked about a possible elevator shaft too. When we went through the plans, he was thinking of the elevator. Let's see, if you go to the lobby.
Here?
Yeah, he was thinking on the left, like
So,
the open area in the lobby as a
okay,
potential for it.
so let's
It's
say-
not. I don't think it's required in our current design due to the amount of floor space we have.
But anyways, if we really need one, I think this square would be the best one, because if we look up, it's still kind of open here, nothing disrupts here. And then when it goes up, it still kind of hits the like the entrance, but I guess like the staircase next to it can be shifted. Yeah, it can shift a little bit to move the space to have the clearance to go through. Yeah, just in case it really needs one, then maybe this location would be yeah.
Yeah. We should, I guess, double check. He seemed to think it was a benefit to the design just in general. So
but
I think
maybe
probably
maybe engineering team can also like do a quick calculation if like putting an elevator system would like undermine the energy performance quite a lot, because I'm like
Yeah.
elevator may take a lot of electricity to do all the work.
It does, like adding an elevator. I totally hear you with like the ADA requirements, but like just thinking about like zero energy requirements, and like kind of trying to mitigate our energy use, like an elevator adds like an entire new element of complexity.
Okay.
And like if we're trying to like, we're already like gonna have to come up with some really innovative ways to make to lower our energy use intensity, which is kind of the metric for having like a really like energy efficient building. Just with like with kind of the nature of how many units we have on a single site, and just like the typical need for like energy or electricity. So I would say if we can, maybe keep out the elevator if possible. That's just my 2 cents with it.
Okay, that sounds like a reasonable decision. In that case, what Todd did mention is that on all the ground floor units need to be super ADA accessible. So includes the bathrooms and kind of all the radiuses around the openings and stuff. So we should just go back through that and double check that they all conform.
Yeah, sure.
Do anyone else have any other questions, or would the engineering teams like to present?
Yeah, we could talk about I mean, just kind of high level stuff. I think that I wanted to ask about the like energy modeling stuff to maybe Adriano. Do you know kind of the extent of like how we're supposed to use like any energy modeling software, or like if we really need to dive in on that kind of stuff? Is he still here?
Yeah.
Oh.
I'm not sure, man. I think we need to go back to the guidelines and check like the minimum requirements. But no, I don't have the answer. Let's look for that this week.
Okay. Yeah. So I guess as for like engineering B, just what I'm thinking about is we're just like still working on like developing actual sizing requirements. So we'll go into the plans here and like try and get some ideas of like some more concrete numbers for next week and like the week after. Jared, if you've got anything else to add.
No, not at the moment. You pretty much said it. Still working on the task that we were been given. So we will get back to you and we'll update you on progress on that front, and we can meet with Adriano as well. And I think also maybe Max will comment on this later on, but when we have that meeting with Amy from Prefab, we can get some more clarification and get our questions answered with regards to the MEPs for our like proposed design. So yeah.
In terms of the kind of energy modeling, there is this program that works with Rhino called Climate Studio.
That might have been
Yeah.
actually what I used, what we were like looking at last year, me and Tomas. So it's like a plugin, right?
Yes, and it basically has a bunch of different analysis features for it. If you guys don't know Rhino at all, it might make sense to kind of do it in conjunction with the architecture team. Like they could, make sure the model was prepped and ready, and then you guys could run the actual analysis or just get the numbers from each analysis. But it does everything from like daylighting and sun path to actual thermal and ventilation. Honestly, it's kind of a lot.
Totally. Okay. I can go ahead and look into this a little bit because I have Rhino on my computer too. So I can kind of play around with it and get a better understanding of what actually goes into it.
Yeah, we did get a free copy of this software, so
oh,
I can
awesome.
send it out to people who request it.
Cool. I would love that.
I'll email it to you, Sterling.
Is there anything? If not, I'll just make a final announcement before.
I think you're a little quiet, Max. Can you
Hear me again?
Yeah.
Yeah. If you guys have anything to add, please just keep on going. Because when I jump in, it's going to be like a ending announcement for the meeting. Yeah. Because I have a few more things that we have to discuss upon, logistically.
Okay, here's the Find the Studio code in the chat, by the way.
I think I have a little thing to add to the intersection between the podium and the wood portion. I'm gonna can I share my screen real quick? And then I'm trying to do AirPlay. AirPlay. Sorry, I don't think it's gonna work. Here, can you see my screen?
Yeah.
So like if we do a section cut right here to A, so this is the steel section, and then this is the wood. All right, and then we go to the detail. So like right here is the detail that I just drew. So if the deck's gonna be like 4 inches, like this is gonna be 4 inches. Like this. And then this is gonna be 12 inches. And then from the interior, this is interior, going to the exterior, I think we need, the code requires like a minimum of like 1.5 inch step. So like this. And if we're going to have the pedestal system that like Gavin mentioned, we could possibly do this because like we still have like about 8 inches left right here. Well, 7 inches. I think it's feasible. And the thing is like if water like runs through and hits the deck, I think we still need to do some like a sloping system below. Because like if we were to drill a hole right here and let the water drain through here, I don't know, like the concrete still need to slope, and then so the surface can remain like flat. So this would be flat. And this would have a slope. Does that make sense?
Yeah, the pedestals could sit on top of that slope, right? because they're
Mhm.
adjustable.
Yeah, because it's adjustable. And then another thing I want to point out is like along the periphery, there's gonna be like a drop beam, a drop steel beam to support the deck. So this is the metal deck. Sorry about my handwriting. This is a metal deck. And I just don't know, like, if this is like, the head height is gonna be like 10 feet. And I don't know how deep the beam's gonna be depending on the load that's sitting on it. Like, do we have like a head height for the
I think for the I-beam portion, I think it would still falls to the exterior part of the building. So let's say I think that would be enough because let's say floor to floor for 10 feet, even with like 1 feet kind of height of the I-beam, I think 9 feet is still sufficient for parking. And even though let's see, like the end beam that you're mentioning does not really place on top of any car park spaces. So yeah, I think that should not be a huge concern.
Okay, cool. So we will go with this system.
Yeah.
Okay,
Yeah.
cool. And then I think the waterproofing would just like go around here. Here.
Like an L shape, right?
Right, yes. So simple enough. And then another thing is right here. I think we're going to need a steel beam right here. So here would be wood beam, just like a rim board, and this would be steel.
Sorry, but for the steel beam you were mentioning, is it integrated to the wall panels or it's right outside?
Right outside, it's
Okay, yeah, that would be fine. Yeah, as long as they don't clash or overlap with the wall panel kind of stuff. Yeah.
okay. All right, and then I calculated the size of the column based on it. This is 23, right? Wait, no, 26. This is 26 feet. And this is 11. I think we need a column size of minimum is 8 by 8. And I saw that you put like more columns along this length.
Yes.
You put like one right here, one right here.
Basically, every 13 inches would have a column there.
In that case, I think 6 by 6 would work.
Okay, great.
Yep. Cool. All right, that's it.
The diagram looks great in terms of determining the final materials and sizing.
Thank you, Kaiji. So is there more you guys want to add to the meeting? I guess no. Yeah, I'm just gonna pause the recording right now because I'm gonna basically going to just share the